This is Adrien de Beaupre. I'm sure I messed this name up, but I try every time. Adrien, if you're listening, if you can hear me, I try to get your name right. I've known Adrien for, I think he's been a SANS instructor as long as I have, over 15 years. And he lives up in Ottawa, Canada. He is one of the leads of the B-Sides Ottawa conference back in the past, not anymore, but I believe quite a few years ago. He is a principal SANS instructor, one of the authors of Sec 460, which is a course on vulnerability management and scanning. Also the lead author or sole author of Sec 642 on advanced web app penetration testing. So with that, I'd like to welcome Adrien virtually.
All righty. Good morning from Ottawa, Canada. I looked up this morning and we have snow. Welcome to the Great White North. Welcome to my talk. My name is Adrien de Beaupre, and we're going to talk about attacking JWT or JWT, very common in modern applications. So briefly, what are they? So JWT are actually, according to RFCs, JSON web signatures. So the purpose of the JWT is you will authenticate to an application, perhaps over a REST or GraphQL API call, then you'll be assigned a JWT. And the JWT will be a signed piece of URL safe, basic for safe encoded content that asserts, for example, who you are. Might have your username, your user ID. It'd have other things like, when it was issued and when it expires. So you authenticate, you get a JWT. It's base24 encoded, URL safe, and contains three parts, right? There's the what am I, there's the assertion, and then there should be a signature. Now, there are a number of different supported signatures, algorithms, and we'll talk about them fairly shortly. Often you'll see them in a header. And again, you authenticate, you get your JWT, and then you can use it to assert your authentication and then have access control performed by the application on your behalf. Usually stateless, meaning that you have to present your JWT every time. So first off, there's the header. Basically, it asserts what I am. I'm a JWT, and the algorithm I have in JSON or JavaScript object notation format. Now, a bunch of different claims that are in there. For example, issued at, issued, expiry, and others. But you can put in there whatever you want, right? User ID, username, password, role, right? So the signature is supposed to be an integrity check, right? To prevent tampering, right? Modification of the JWT. And there's a bunch of different algorithms. Some of the common ones are HS256, RS256, and ES256. There's another one called none. And you're wondering, like, well, is that a signature algorithm? No, it's actually not. It means that there is no signature. And if there's no signature, that means we could change it to whatever we want and send it back. I guess that would be a bad thing. So here's an example of a JWT on the bottom, right? So there's the header, which would be the, as mentioned above, the type and the algorithm, for example. Then there's the assertion, right? User ID, etc. Then there's the signature. So if there are three parts, it indicates it is signed. If there's only two parts, it means it's not signed and there's no signature, meaning the algorithm of none. Now, most modern implementations of JWT do not support the none algorithm, even though the RFCs say they're kind of supposed to. But RFCs, right? Who follows them? Like, do you really have to follow the RFC? Well, you kind of should maybe, but whatever, right? So code to make a JWT, here's an example in Python. You just import the JWT library, the module. For example, in this case, we have a secret of secret and a payload, right? User ID. Then you sign it, and then you perhaps also decode it to determine, did it work correctly? Now, you could do this individually, like you could actually create a JWT by hand, but most often you use a library to do so. So in this case, notice that the secret is kind of short. And in fact, yes, there are tools to crack JWT secrets. So security issues. One, base64 is a reversible function, right? It's effectively in the clear, meaning that with common tools like Burp Suite Pro or Burp Suite Decoder, or CyberChef, or just basically online, any base64 decoder can decode them, right? If they're accessible, they could be perhaps stolen by an attacker, and there's no easy way to revoke them. Like they have an expiry date, for example, but you can't say, okay, that JWT is now revoked. You'd have to do some code server side to say, okay, we're not going to allow that one anymore. What if they don't even bother validating the signature? Or if you remove the signature and send it in without the signature, do they allow that anyway? Is it possible that I get a JWT from, for example, one server and try it somewhere else and see if it works? Now, the most common problem here would be if they allow the none algorithm. This would be a server-side configuration where typically you would want to specify which algorithm is allowed. And notice I say algorithm singular. But what if they allow basically any algorithm, such that if you change the algorithm from whatever they told you it was to something else and send it back, that might be allowed. You can crack the HS256 keys, right? Using common tools, which I'll show you in a sec. There's an algorithm substitution. If they, for example, sign using RSA 256 with the private key, you then change the algorithm in the header to HS256 and then sign it with their public key. Again, if the server is misconfigured, this might be allowed. There's also just stealing the private key, for example, or stealing the secret or cracking the secret. And there's a whole bunch of X509 issues, which won't get into great detail because they're not very commonly implemented. I gave this talk to a bunch of folks at AWS, or part of this talk, and they actually told me that they actually encrypt their JWTs, which is not the most common implementation. The most common implementation is effectively base64 encoded, which is in the clear, and signed. However, not encrypted. And they told me, well, they actually encrypt theirs. Like, oh, great, that's cool. So to identify the algorithm, you just take the header and base64 decode it, right? That's super easy. And you can see that, hello, I'm a JWT, and hello, my algorithm is whatever it might be. So Burp Decoder, Python, base64-D, CyberChef, etc., can all do this kind of stuff. Super easy to do. Now, the none algorithm, interesting enough, you can tell just visually if they're using it, right? The JWT only has two parts. So the header, the dot, then the assertion, then the dot, then nothing, right? So fairly obvious that this is signed with none. Now, if they do so, all we have to do is decode it, change it to be someone else, for example. Being someone else is so much more fun in web applications because as far as the application is concerned, you actually are the other person. It's like role play, but even better, right? And then you become the other user or change your assertion to be whatever it is you want. Then you submit it and boom, you are whatever you want to be. Which, where do you want to go today? Various different tools to use to crack HS256 signatures. John the Ripper can do it. There's a specific one called JWT crack, which I found took a really long time, so I haven't used it in demos. There's also Hashcat, has a mode 16500 specific to JWT. In this case, I'm using the password list from John the Ripper. So various different ways. Typically put the entire JWT by itself in a file and just crack against that file. So algorithm substitution, this is where they have signed with the RSA private key. We have a copy of their public key. We re-sign the JWT with the algorithm of HS256 using the public key. And again, depending upon server configuration, this may be allowed, right? And then you just create the JWT with their public key and away you go. Now, there's a tool called Joseph. Now, if you look for Joseph in the Burp Suite the App Store, it's actually called the JSON Web Token Attacker. Although if you look at it in Beaupre, it says, hello, my name is Joseph. So various attacks you can do inside of Joseph. One of them is to change the algorithm to none. So you feed it the JWT that you got from the server, and then it'll try none, all caps, none with capital N, none, all lowercase, and then none with the O capitalized. And in this particular implementation, it allows the none algorithm, even though we are given a signed JWT, either H256 or RS256. And so again, server side, the configuration of the JWT algorithm server side is misconfigured. So this is built into the Joseph tool. Oh, there's something in the chat. Yes. So you can also do this manually or write a Python script. Now, quick personal story, and I tend to share a lot of things, personal stuff when I'm speaking and teaching, is that Pearl and I had a nasty, nasty breakup in the year 2000. And Pearl and I had that nasty breakup because I met Python, and Python was like, oh, come try me. So I tried Python and I was like, whoa, I can actually read my own code and it actually makes sense to me. But if I go back and look at code that I wrote in Perl from many years ago, it's like, I don't even know what it does anymore. So here we're using the intruder feature of Burp. So we find the post to login, for example, and then retrieve the get where we actually have used the JWT to access the application. And basically you just fuzz the header, right, with the algorithm of none. So you could put in many more variations of the capitalization of none, for example. And you can use one of the features of Burp in Intruder to, for example, take the changed header and basically for encode it, URL safe encode it, drop the equal signs at the end and submit. And that's in fact what JWT does. It basically for encodes, but then URL safe encodes it such that there's no plus signs or slashes and changes those to safe characters. Then it drops equal signs at the end, right? So here we change, for example, they gave us HS256. So we add the prefix, right, of the algorithm of none. We add a suffix, we basically for encode it, and we take out the equal signs so that we can resubmit the encoded header with our new payloads and determine, okay, does the application actually allow? But with Intruder, for example, unlike Joseph, Joseph will resubmit the same assertion, meaning that you have not changed your username, you have not changed to someone else yet, you've basically still yourself. That's boring. You want to be someone else, right? Always choose to be Batman. No. Neo? Anyway, someone. So in this method, we can actually not only change the header, but we could change the payload as well to change our assertion to something else. So Joseph also supports a signature exclusion attack. So you find, for example, the get to the application that uses the JWT, usually often in a header. Then you send it to Joseph and use the signature exclusion. So this one came with RS256. You then load the signature exclusion and hit attack. And then it'll open up a new window that kind of looks like Intruder, where it tries to exclude the signature and basically send, although it does resend the same assertion again, such that it doesn't change who you are as far as the application is concerned. So signature exclusion, again, here trying things like none, right? Again, with various cases. Now, similar to Intruder, it sends a baseline request that is unmodified. And then it starts changing stuff to none, 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 right? So various different ways to use the JSON, WT, web token attack tool in Beaupre. But of course, all these attacks can be done manually in Python, which is actually some of the demos I typically do and I'm going to do, in that, you don't need a fancy tool, just write some code. Use the source, Luke. No. Source? Anyway, something like that. So Joseph calls the switching from RS-256 to HS-256, calls it key confusion. So you'd find the request with the appropriate header, right-click, send it to JSOF, Joseph, load the attack, and then paste the public key. So it'll strip off the RS-256 signature, change the header for you, sign it HS-256 with the public key, and then you submit it to see if you, again, become someone else or change your assertion. So this key confusion attack in Joseph actually will use many, many more than just HS-256. In this case, it uses about 20 different variations or different key lengths for HS-256, and it'll determine which one of them work. In this case, because I wrote the application that is deliberately vulnerable, it allows all of them, right? And we do this a lot in the course that I teach most often, which is 642, the Advanced Web Application Penetration Testing, Ethical Hacking, and Exploitation Techniques course, of which this content will become part of that course. And actually, it's already written. It's actually going to be released and will be released at the next teaching of this class. So this content will be, although expanded in the actual class with exercises. The application I modified. I took an open source application, modified it, made it deliberately vulnerable such that all these attacks work. Now you'd think, well, Adrien, that means these attacks wouldn't work in modern frameworks, right? With modern libraries. Well, I would check, right? So again, with the key confusion attack in Joseph, it sends a baseline that's been unchanged and then tries a large number of different variations on HS with different key lengths to see what works. So conclusion, these JWT or JWT assert a claim, most often used in REST and GraphQL APIs. So you log in over the API call, you get your JWT, and then you send in your JWT for every subsequent request, right? There are three parts. They are basically for URL safe encoded. There's the header, there's the claim or claims, the assertions, and then the signature, right? There's the client. There may be a separate authorization server from the resource server, or they might be the same. There's a whole whack of different attacks. And if you can, of course, modify the assertions, it might be possible to do denial of service, might be possible to do SQL injection, right? Whatever the assertions are used for server side, there might be other forms of injection attack that are possible against that server. So you can crack HS-256 secrets, you can do signature exclusion, you can do the swapping of the algorithms. There are a whole bunch of potentially vulnerable libraries, but most often what we see is our implementation issues, right? Where decisions made by either the person who designed the JWTs or the people who implemented it, server side, make decisions that are perhaps less than ideal. If that makes sense. Everything makes sense in my head until it comes out of my mouth. Then, So, demo time. Oh yeah, I still got time, good. So let's see if I can switch to the virtual machine and see if that's what you see. I can't see what you see, so let's try new share, screen one, and make sure that that's what you see. There we go. So I've got the servers already running, and I have a bunch of Python files that we're going to run. So for example, first I'm going to log in, and my apologies for copying and pasting, but I'm a two-finger typist, have been for decades. So I don't like typing stuff. If I can, I write a script. If I can't, I pick copy paste. So this allows me to log into the server. So HTTP or HTTP is just a HTTP client like curl wget, running it through a proxy of Beaupre running on localhost, format of post against localhost port 8000 /login. So that's my URL, my resource /login, the REST API endpoint. My email is user1 and my password is password. So authenticate, and I'm not running Beaupre. Loser. Demo fail. I always ask for a virgin live goat, particularly a younger goat, such that you sacrifice the goat so your demos work. I obviously failed to do so, but that's okay. An extender. I want the JSON web token attacker. So that's actually Joseph. All right. So I log in and I get this time a token, right? Notice that it has 2 dots, but nothing after the second dot, which tells me that it's using the algorithm of none. But I can double check that. Identify the token here, token header, by sticking the header in here and doing the decode using Python. Okay, it wants equal signs. One will do the trick. There we go. So it says I'm bytecode, right? I'm type JWT, algorithm none. So I can tell right off the bat that this guy's none. So, right, I can just do change my none, right, from the old token, decode it, change my payload to user ID 2, and then send the new token, or give me the new token. I can then authenticate with it. So I'm going to authenticate with the existing token, which actually has a limited life. So I'm going to re-get it. Oops, I need this first. So I'm going to use my token now that I've authenticated. And system user 1. All right. So if I do swap none, signature O, okay. I didn't put in the new one. That's the old one. Right. So this is my new token. The old one, I'm user ID 1. Now I'm user ID 2. All right, so that's none, right? Who would use none? All right, let's try a different. So indicate against 8001. All right, So now I have a token with 3 parts. Notice the signature is not that long. So that tells me that it's probably HS256. Identify the algorithm. And tells me I'm HS256. All right, so what can I do with that? Well, I'm going to try and crack it. Using John. And it says my secret is secret. Okay, now, obviously, since I wrote the code, I made my secret secret so I could make it super easy to demo. So you could say I cheated, but you know, there's no such thing as cheating in penetration testing. There's rules of engagement, there's scope, and there's everything else that's allowed. So this would create a HS256 with a secret of secret with my user ID 2, and then sign it and give it back to me. So now I have a new signature to try. And this one should be 8001. And I'm user ID 2 as far as the server is concerned. I'm going to do the third server, 8002. Log in. Notice the signature is significantly longer, which is indicative that it's probably RS256. Although I can check that by using my identify alg. Oops, too far. Right, so I'm definitely RS256. Cool. But I have the public key, server public key. Right, so that's allowed, right? I'm allowed to have their public key. I do not have, of course, their private key. But let's see if I can do it anyway. So I'm going to do swapping the algorithm. Right? So I'm using JWT. I take their public key. I then make a payload of user ID 2 and then sign it with HS256 where I'm using their public key as the secret. So now I have this as my new token. Notice that it's, again, significantly shorter than the RS256 signature. And it says, hello, user ID 2. Whereas, just show you the proof in the pudding, right? If I use the original one, or is the proof in the eating with the pudding, something like that. Right? So I use the original signature, it says I'm user ID 1. I'm not administrator. If I switch to 0D2, I am administrator. Wow, I think I actually finished with about 3.5 minutes to spare. So again, this content is part of the newest version of 642, the Advanced Web Appendix course from SANS. And I will be around for questions. I'll also be in the hallway, probably for a couple hours. Please feel free to reach out. There's my email address, my Twitter, and my name. Again, Adrien. Just call me Adrien. And I guess that's it for me.